My name is Roger Boulton. I'm a professor of chemical engineering and Enology here at the University of California at Davis. Behind me is a building which is a winery and a brewery and a food lab, which was built to be the first LEED Platinum building on the Davis campus and the first LEED Platinum buildings of this kind in the world. That's the first feature of them, and you may hear some noise in the background from a class that's currently running. But we have a vineyard to the west, which is the source of our grapes for our teaching program. We have winemaking classes, which are in session right now. We have brewing classes, and we have a range of other activities that go on in this building. One of the most important features of it, it was designed to become a self-sufficient winery. That is, self-sustainable in energy and self-sustainable in water. And what that means is being independent of a power source from the outside and being independent of a water source from outside. And it's the kind of model that will be used in many different places in the world, which today you probably couldn't have that business or an activity because you'd have to be hooked up to a power line or you'd have to be hooked up to a water line. So this is a model for other people to take and use in lots of other places. One of the key features of this building is the integration of rainwater tanks into the architecture of the building itself. And if you can look behind me, you'll probably see 4 large shiny tanks which capture the rainwater from the roof of this structure. And that's essentially a year's water supply for all of the toilets and landscape water applications that this building uses. And as such, it's not only net zero water, it's actually a water positive building. And we hope that in the future more people will build water positive buildings. The challenge usually comes is we use a lot of water at certain times of the year, in the harvest time, like now, when there's no rainfall. And the rain comes in January, December, maybe February. And the challenge is how do you capture that and how do you store it? And that's a rainwater tank. So this is an example of how to build a building that captures the water from its own roof to be used at another time in the activity that goes on in the building. And how to build rainwater tanks into a structure that makes it acceptable architecturally. And I think that's what we've achieved here at school. To my left is another building which is called the Jess Jackson Sustainable Winery Building. And this is a building which was built to house a number of systems which will allow the winery and the brewery to operate completely independently of outside energy sources, of carbon-based energy sources, and of water sources. And so it will capture, with more rainwater storage tanks, roof water from our main institute building. And that rainwater will be used for the cleaning of all of the equipment within the winery and the brewery and the food labs. One aspect is water and storing it in rainwater tanks. The next aspect is being able to use water more than one time. And this building was designed so that when we wash the tanks in the winery or the brewery, we can actually capture that water, filter it again, and reuse 90% of it a second time, and a third time, and a fourth time, and a fifth time. And if we could go far enough, we could probably use it 10 times. The challenge will be how much energy do we want to spend versus how many times do we want to use it. But if we only used it one more time, the number of storage tanks would be half. And if we used it 5 times, we're now talking about a fifth of the number of storage tanks. And if we could use it 10 times, now we're back to a few rainwater tanks. So there's a linkage between rainwater tanks, the number of them, and how many times we use the water. And what we're trying to illustrate here is an example that's applicable in all of the food industries, all of the brewing, fermentation industries of the world, where water to clean equipment is an essential commodity. The last feature of this complex is it was built to be carbon-free. And I don't mean carbon-free by trading and compensation of emissions from grapevines. I mean a building which actually generates all its energy free of a carbon source, solar and hydrogen, and creates a condition under which the fermentation gases from our winemaking and brewing get sequestered on site to be calcium carbonate. That means there is no carbon footprint from this facility as we operate. And there's no other structure like it in the world when you look at the carbon content aspect, the solar on-site generation, the water capture and reuse, that these buildings embody. So one of the unique features of the Jackson building is a structure that will house advanced technologies. And those advanced technologies will allow us to recapture the water and use it again. With solar power, refilter the water. And to do that, we need a membrane system which typically would take away dust particles, take away yeast and bacteria, take away viruses, and filter that water under high pressure, powered by solar. And so one of the rooms in Jackson is set up for such a system. Another room is set up for a similar system which will be used to recover the cleaning solutions each time we use them. And so those membrane systems are what we're looking at installing in this location. We already have an opportunity to install a solar thermal hot water system in one of the other rooms. We're in the process of doing a design and installation of another system which will use solar power to create ice cubes, which becomes the cooling water system for the winery. And we're currently looking at proposals and entertaining options that would allow us to put in hydrogen generation from solar on site to create a hydrogen-based fuel cell that will run in nighttime and off-peak conditions, and a bay which would allow us to use second life lithium batteries to be able to be charged up during the day to actually operate components in the winery at nighttime. And so those technologies are the kinds of things which we can install in a building if we have the building. And the Jackson building is the enabling building that's going to make that possible. The last and perhaps most critical feature of this complex is being able to take the water from our main institute building, the Robert Mondavi Institute buildings, and instead of directing it back into a creek or a water system, to redirect it to these tanks so that we can transfer that rainwater over here, filter it, and have it become the water system for the winery and the brewery complex. And that's a task we still have to accomplish.